Hello and welcome to DevSecOps Fundamentals Workshop. Today's webinar is sponsored by Sneak and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I'm excited to be your moderator for this special workshop presentation. Now, before we get to today's great session, we do have a few housekeeping items that are going to help you get the most out of it. First off, we want this to be an interactive and informative event for you, so we encourage any questions in the questions box in your webinar control panel. So not only will we have team members responding to questions during the live event, we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail as many of the questions that you ask as we can get to. Now, that Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues. But if that doesn't work, just let us know there in the Q&A, and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a link to the Sneak homepage and a white paper provocatively asking, is DevSecOps dead or is it? There's also a link to access a webinar on the anatomy of a successful DevSecOps program. So I encourage you to access those resources now and feel free to share them with your friends and colleagues. Now, third, at the end of this webinar event, we'll be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the link with the details there. Now, finally, one of the best benefits of this event is that opportunity to ask a question of our expert presenter. So to help encourage those questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event's over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. Okay, with that housekeeping out of the way, let's get to today's presentation and demos. So I'm excited now to bring on our expert speaker, Micah Silverman, who's Director of Developer Relations at Sneak. Micah, welcome.
All right, good day, everybody. My name is Micah Silverman, and I run a team of developers and security folks over here at Sneak. And I'm not going to go into great detail on this slide, but I do like to cover the first and last items here. One is I've been a Java developer for 29 years since it was released in beta in 1995. And this is the point at which I usually like to say, get off my lawn. But I also program in a number of other languages, and my entire career has been shot through with security. I've just always been interested in security. I was a hacker from an early age and transitioned from kind of a gray hat to a white hat hacker over time. And the last item there is chaotic neutral. And some of you may know where that comes from. I always like to identify my fellow nerds in the house early on, but that is an alignment and it comes from Dungeons and Dragons. And you can be chaotic or lawful or a whole bunch of other things. You can be good, neutral, or evil in that game. The reason it's relevant here is because when we're talking about application security and hacking around systems, I'm going to invite you to hack on a public website a little later on, and it will be my delight if you can find a vulnerability and crash the site. But it helps to have that chaotic mindset. We provide kind of inputs to a system that are unusual or unexpected, and then we get unexpected behaviors or unexpected outputs. So I want to invite everybody to kind of embrace that chaotic mindset today as we go through this. All right, so we're going to focus on developer security and really why developers should care about security. If you've been around a while, as I have, back in the day when they started talking about developers need to start considering and working on tests and have a test suite with their app, with the applications they're developing, well, that was met with great resistance at the time. I have a QA department, and they have a script and they go through the app, and if they find issues, they send it back to us and we fix it. What do I need to write tests for? Well, fast forward to today, and you can't imagine an application of any serious size not having some sort of test coverage in it. And we're finding that same cycle kind of repeats with security. When we start talking about shifting left and having developers be responsible for at least part of the security landscape of their application, we see a similar sort of resistance. Like, we have this security team, they're really great at what they do. I don't want to become a security professional. We hand off the application to them before we deploy, and they let us know if there's any issues. Well, it turns out when you use tools like Sneak and you have a culture and processes that support developers in caring about security as they develop, it actually improves the speed of development because you're getting less things kicked back from your security team, and you're catching things earlier in the software development lifecycle when it's easier to do so. So we're going to talk about why developers should care about security. We're going to look at the Sneak tool set in particular, and we're going to hack on a web app together and see how Sneak can help with that. And then we'll wrap things up with kind of a section on DevSecOps in action, and we'll have time for Q&A, and we have a lot of resources to look at as well. All right, so when we talk about security from an application development standpoint, we're really looking at our code that we write, our dependencies, and then security below the surface. And then we'll look at some strategies for defense in depth. So first of all, why should developers care about security? Well, a couple good reasons. One is our applications are often handling sensitive user data, and we want to be part of a total solution in protecting that sensitive user data. Now, of course, we have our DevOps people and our DevSecOps people and our security teams to make sure our architecture is good and we have the right firewalls in place. We're not saying that developers need to become security professionals as well. We're saying that we need to kind of embrace a part of the responsibility so that we can do things like protect sensitive user data. Sometimes we have to ensure regulatory compliance, especially in the world of GDPR. If we're writing applications that the European Union or other countries are going to be using, we have to make sure that we're handling that data in the right way. We want to reduce the cost of breaches, and this one kind of has an asterisk. You may be saying, well, we don't want to have breaches at all. Yes, that's absolutely true. Ideally, we will never have a breach, but we want to consider, well, what happens if we do have a breach? What's the blast radius of that breach? Is my data encrypted at rest so that if that database were compromised, it makes it that much harder for attackers to do anything with that data? We need to protect intellectual property. That can be both our company's property and anything that we might contain within the applications that we're building. We want to ensure business continuity, and this is kind of a subtle one. Oftentimes, attackers' only goal is to disrupt or discredit businesses. Maybe they're not even interested in a breach or compromising or getting access to your data. Maybe the only goal is to embarrass the company in a great way, in a grand way. And that could look like just launching a distributed denial of service attack and disrupting the website, the application, etc. We want to establish and build trust with customers. Trust is very hard to build and very easy to lose. And so it's important that we have a care when it comes to our application security. And we want to address this growing threat landscape. And I will never be the one to spread fear, uncertainty, and doubt, but I also go in eyes wide open and understand that as a developer, we have a much bigger threat landscape than we used to. By that, I mean developers have to start caring about things like if there's a Docker file in your application, in your repo, there's more that you have to care about than you used to have to care about. Now we need to know, well, is this Docker file properly secure? Is it everything running as root? Are there open ports that shouldn't be? These are things that maybe we didn't have to think about in the past. Now, when we talk about supply chain attacks, they affect all ecosystems. And, I like to poke fun at the JavaScript community. As a Java developer, we have a friendly competition at Sneak amongst our developer relations team. We have a number of a variety of languages represented. And I do think that JavaScript tends to make maybe the most frequent or the most splashiest sort of impact in the news when something goes wrong. But we're actually going to look at two Java examples, just for me to be fair, of supply chain attacks. But the big takeaway is that they affect all ecosystems. It's not relegated to one language or one framework. And part of the challenge is that we're in this situation where we have to have this implicit trust of these ecosystems of libraries and dependencies that we use. So when I'm building a Node.js app, I type npm install React, right? And magically, half of the internet is downloaded onto my laptop, but now I have React in my project. Well, where is that coming from? And how much do I trust that network interaction where I've downloaded potentially multiple gigabytes worth of data onto my laptop to now go and work with it? And by and large, these systems are only beneficial to us. We couldn't be where we are today with the state of the art without these ecosystems, but it's a double-edged sword. We have this implicit trust. And let's look at two kind of case studies and how much different they are over the course of time as the state of the art has progressed. So we have to wind back all the way to 2017, which is like a lifetime ago in internet years when we talk about the Equifax breach. And if you're like me, a couple of years ago, I got a check for $2.37, which represented my cut of all the lawsuits that had been resolved over this. But the reason that we keep coming back to this particular breach is because it's a class of breaches that's heartbreaking to me, and that is entirely avoidable. And just as a data point, it's cost over $2 billion so far. That's everything from legal fees to real damages incurred by people's data being sold on the dark web. It affected fully a third of the entire population of the US. Now, we're not going to go over this entire timeline, but what I mean by entirely avoidable is if we look back to 2017, Apache was notified of this vulnerability February 14th. 3 weeks later, March 6th, Apache releases a fix for the vulnerability. And this might, for the naive technology person, we might say, great, problem solved, we're done, it's fixed. And really, that's kind of ideally how it should have played out. But as you can see, we have a lot more to this timeline because that's when attackers go to work. When a vulnerability like this, an especially gnarly vulnerability that results in the ability to completely take over a system, when details of that are released, that's when attackers go to work because they know that there's going to be some subset of companies that don't update their software in a timely fashion. And we've seen this a lot with companies and systems that are stretched thin when it comes to technology resources. That's unfortunately why hospital systems and education systems become such targets. But it is a little shocking that a company as big as Equifax, kind of fell under this. And so what happens is when the vulnerability is released and details of it are released, researchers legitimately, for legitimate purposes, come up with proof of concepts. That's important for a number of reasons, not the least of which is to validate the severity of the vulnerability. Well, from there, a bunch of script kiddies come along and they take these proofs of concepts and maybe enhance them or write their own, and then attacks begin. And it's unlikely that Equifax was initially a primary target. It's unlikely that attackers said, let's go get Equifax. What's more likely is that they were doing a broad sweep of the internet looking for the fingerprints of an outdated version of this Apache struts library. And then as soon as Equifax came up as having those fingerprints, then Equifax for sure became a primary target. And so what we learned by this massive breach is that we really need to detect fast, respond fast, and we need to be able to do it at scale. And obviously that did not happen in 2017 with the Apache struts vulnerability and exploit. But if we fast forward to 2021, so 4 years later, we have the Log4Shell vulnerability and exploit. And we're not going to go into great detail on this slide, but it's useful to point out a couple of things about this. With 4 years under our belt, many companies were using services and companies like Snyk to actively monitor their environments for new vulnerabilities. And if you're a Java developer or you know Java developers, on December 9th, 2021, all was right with the world. And then on December 10th, everything was on fire. And it wasn't because of a new version. It wasn't because of an update. It wasn't because of a malicious attack. It was that a new vulnerability had been discovered. And this is the other key point about why developers should care about security. This is not a static thing. It's not, well, we've driven out all of the security vulnerabilities and now we're done. New vulnerabilities are discovered all the time, and this is what happened with Log4j. In case you're not familiar, Log4j is the most popular logging package for Java. In our research, we found that over 60% of Java projects in production in the world used Log4j. So significantly more than half. And, the humble logger, its job is to write output to log files or to databases. It's a very important tool for tracking for developers and sometimes for regulatory compliance. It's very important to have a good logger and a good logging system. But what happened was a new vulnerability was discovered, and it was about the most serious one. It could result in remote code execution and potentially remote takeover of a machine. And it was dubbed Log4Shell because one of the first proof of concepts showed how you could set up a reverse proxy and end up with shell access to a machine that a Java application was running on. Now, the difference between 2021 and 2017 was that within hours, not days or weeks, within hours, we had remediation advice. This was a network based attack. And it turned out that if you could block LDAP access, lightweight directory access protocol, if you could block LDAP requests at your firewall, outgoing LDAP requests, that immediately stopped this attack. And if you had a legitimate use for needing external LDAP calls, well, then the advice was let's set up an allow list. So only your allowed LDAP requests will go through, because the nature of this attack started with making an LDAP request to an outside server that you had no control over. It wasn't your server, it was just a publicly available server. So within hours, we had this remediation advice, update your firewall rules. Then within days, not weeks, we had an update to the Log4j library. And if you were a Snyk customer, you would have gotten a notification from us because you were actively monitoring production saying, hey, there's this very serious issue. Go look at our remediation advice here. So fast forward 4 years, and as far as we know, there were no active exploits, for sure nothing on the scale of Equifax, but maybe not any at all as relates to Log4Shell, because the state of the art had progressed. Developers, development teams, DevOps organizations, companies in general had gotten more savvy about these kind of attacks. And again, if you were actively monitoring your production, as we recommend that you do, you would have gotten a notification that there was this very serious issue that was discovered, and you would have had this very quick remediation advice. So with all that behind us, now let's take a look at what the security landscape looks like for developers. And it turns out that what we learned in grade school about icebergs maps onto the modern application very nicely. And if you remember, when we talked about icebergs in grade school, the tip of the iceberg, what you could see was actually the smallest part of the iceberg. That's what was above the surface. And the vast majority of the iceberg was below the surface, those parts that you couldn't see. Well, it turns out for application code for developers, the tip of the iceberg is the custom code that we write in our applications. And it turns out that only 10 to 20% of a modern application is custom code. And that's what's above the surface. That's what we can easily look at. That's what we contribute to. And if you look at this code, this is some JavaScript code. If you're not familiar with JavaScript, you may be able to kind of parse out the elements of it, even if you're not familiar with JavaScript. This is kind of a typical web request handler. We have a request and a response object. We have this thing called user, and we're calling a find function on it. That's probably a database. Maybe it's Mongo, maybe it's MySQL. Don't know, maybe don't care at this point. we can see that this find function, we're passing in a username and password. Now, just eyeballing this code, you may see a problem with it, as I do. Ultimately, we don't want you to rely on your eyeballs. We want you to have tools and processes in place that alert you so that you can still move fast as a developer. Now, if you're looking at this code, you may recognize a classic cross-site scripting or injection type attack. And that is this class of attack or this class of vulnerability is when we have an input that we don't have full control over, like a web request. Maybe somebody submitted something on a form. We don't have full control over that. And we're passing that forward without any sort of inspection or sanitization. Now, we might say, well, maybe the find function does the sanitization, but that's actually a code smell if that's the case, because we want our functions to have kind of a primary purpose. We want to have separation of concerns, and better code would be something in between here at line 2 that takes this input and sanitizes it and then passes that sanitized input into the find function. So if you're an experienced developer, especially if this JavaScript looks familiar, you might have called that out. You might have seen that very quickly. But again, we don't want you to rely on your eyeballs. We want something a little more resilient, a little more something that you can use without a lot of overhead, and just run a scan and let it give you that feedback. Now, as we move down the iceberg and go below the surface, we come to our first layer that's below the surface, and that's our open source dependencies. Open source is a great boon to us as developers. If you're experienced the way that I am, if I want to include Markdown as pictured here, if I want to add Markdown to my web application, and if you're not familiar with Markdown, it's a terse markup language that allows you to express in a very compact way things like highlights and links and images and bold and headings. And it parses that. A Markdown parser will parse that terse markup language and convert that into HTML. Organizations or services like Slack use Markdown. You can use Markdown when you chat, and it's a nice way to express yourself in chat, especially. Well, I could, as a developer, I could go and write my own Markdown parser. I could go look at the specification, but it turns out that there are dozens of Markdown libraries in different languages all over these ecosystems. And why would I want to reinvent that wheel? So that's what I mean by it's a great boon to developers. I'm just going to install or bring in this dependency, in this case called marked. That's a Markdown library. And now I get, in just a couple of lines of code, my application now supports Markdown. That's one edge of the sword. That's the great edge of the sword. The other edge of the sword, though, is that this is below the surface. We have no insight into who's contributing to the marked project, how often they release, the quality of the code. We don't have time to go and inspect all of that. So this expands the surface area of attack of our application. And this is what I meant when I said earlier by we have this kind of implicit trust of these systems, because I just type in npm install marked. I read the fine manual, and now with a few lines of code, I have Markdown in my application. As we continue to move down the iceberg and get deeper below the surface, now we have containers, things like Docker and Vercel and Netlify, etc. And this continues to expand the surface area of attack, because now we have considerations that as developers we didn't have to really care about before. Is my Docker file, what image am I using? I like to tell my daughter that the internet is forever, and you can go to Docker Hub right now and you can get the very first published version of a Java image that has 735 known vulnerabilities, almost 300 of which are critical and high. The internet is forever. So what image am I using, and does that image have the least amount of technology in it? One of the very low-hanging bits of fruit with using a system like Docker is to say, well, I'm going to use an image that only has what I need. If I need a Java runtime for my application, I don't need a Node.js runtime in that image also. I can shrink the surface area of attack by making lean images and getting rid of those things that I don't need in it. Finally, we get down to infrastructure as code, IAC, and this is kind of like the container issue on steroids. So maybe I'm using this V1 of the Java image, and now I'm going to spin up 1,000 instances of it. So now I have 1,000 instances through Kubernetes that are all networked together, and they're all vulnerable and ripe for exploitation. And so again, this expands the surface area of attack. And you can see, just by the image at each of these layers, if you have an application, if you're working on an application as a developer that has a Docker file and has a main.tf file for Terraform, well, these are considerations that you necessarily have to have now that you didn't before. For IAC, the number one vulnerability, number one security threat, as researched by the U.S. NSA, is cloud misconfiguration. And we've seen this, for instance, the 119,000 scanned docs in FedEx that were breached due to an unsecured and open cloud storage bucket. That leads to things like this. And these are considerations that developers haven't necessarily had to care about in the past. So when we put all this together, when we look at the modern application, we have 10 to 20% of our code base that's above the surface, and 80 to 90% of our application is below the surface in the form of dependencies and dependencies of dependencies. So at Sneak, we like to talk about code to cloud and back to code. It's not just that we want developers to start caring about security. You're going to scan your code in your IDE and you're done. We want to be testing, fixing, and monitoring at all stages of the software development lifecycle, and especially the often neglected area of production. And this ties back to what we were talking about with Log4Shell, where if you were actively monitoring production, and nothing changed in your production environment, you still would have gotten a notification about this new vulnerability called Log4Shell on December 10th, 2021. So it's not enough to shift left. That's a great start. But we want this virtuous feedback loop where at every release, when you get all the way to deployment, at every release, we're improving our security posture. And so we have this kind of virtuous feedback loop. All right, let's take a look at some strategies for defense, and then we'll get into the Sneak tool set. So first, for open source security, you want to make sure that you have an inventory of all of the libraries, all of the dependencies, the open source components, because you don't want to give hackers more tools to expand their exploits. So maybe during your development process, you were spiking different libraries, and that ended up in your dependency file. You want to make sure that you prune that and you're only left with what's needed. If you were looking at 6 different markdown libraries, you want to make sure that only the one you selected ends up in your dependency file, because why have those other ones that you rejected there and just increase the attack surface unnecessarily? You want to leverage security tools like Sneak. Embrace automation. Anything that I do more than 2 or 3 times manually, I like to set up as an automation if I can, and kind of set it and forget it. So, I have Git hooks set up so that every time I do a new commit, a security scan is run using the Sneak CLI. And if the if vulnerabilities come back that exceed a certain threshold, then the build fails. Just like we fail a build with our test suites if test fails. So I don't want to have to remember to run a security scan. I want that to be automatic. Security policies and action plans are very important. So, for instance, when you're thinking about your company, what happens if you were to get a notification like Sneak would have sent you on December 10th, 2021? What is the chain of events that happens when you get a notification from your trusted security partner, Sneak, saying, hey, your production has a new vulnerability? What's the process to handle that? And then SBOM, you may have heard of SBOM, Software Bill of Materials. That's a way it kind of calls back to this first part. It's a way to enforce that. If you have an SBOM and you've set up the automation to automatically run your SBOM scanner, and what's in your SBOM doesn't match what's in your dependency file, that's going to fail the build. So if I accidentally added a bunch of dependencies, excuse me, but I didn't update my SBOM, well, that's gonna be a fail because I have dependencies that aren't accounted for. So that's a very useful and important part of that. Hold on one second. All right, so when we're talking about containers, some of this is very low-hanging fruit. Hopefully some of this occurs as very obvious to you. We don't need everything running as root, and everything should not be running as root. Again, we want to live in a world, we want to set ourselves up so that we don't have breaches, but we also want to say, well, what if there is a breach? Well, if there is a breach and nothing is running as root, it's a lot harder for attackers to escalate their privileges. There's this thing called privileged containers. Guess what? You almost definitely don't need it, so don't use it. We want to drop capabilities. This is what I was talking about with these lean images. You don't want to have, you may not want to use just kind of a default Linux distro that brings along a ton of utilities that you don't need, like image magic. If you're not actively processing images as part of your application, make sure you don't have image magic in your image. You don't need it. Read-only root file systems are very helpful. I'm presenting on a Mac today, and my Mac laptop has a read-only root file system. It's not a silver bullet, but it does guard against some of the most common types of attack that we saw in the past, where attackers could replace important root files, utilities, and libraries with malicious ones where it looked like your machine was behaving as normal, but all of a sudden now you're involved in this botnet and you see your CPU spike to 100. And of course, you want to make sure that you're deploying from known sources, only pull from known registries. Finally, infrastructure as code. We have to use secrets, but all of them, whether it's Kubernetes or Terraform, they all have facilities and capabilities to manage secrets. They should be encrypted and they should be used and accessed through role-based access controls. So as an administrator, I can create an encrypted secret, and then a non-administrator may be able to make use of that secret, but they can't see the secret. That's very important. So role-based access control. Security context can help enforce security policies in the runtime. Network policies start with, I love this, one of the reasons that security teams and development teams have traditionally had kind of maybe a little bit of tension between them is that security teams start from a place of allow nothing, deny everything, zero trust. And developers, well, we're writing applications that people have to use. So where is that line of where we trust? Well, when it comes to networks, start with zero trust. Don't open any ports, don't allow access to networks, and then open the door just a little bit only as necessary. And then finally, using systems like open policy agents, Gatekeeper and Caverno are Kubernetes specific examples, but those open policy agents can enforce those policies that you stated and ensure that you're not violating your own policy inadvertently. All right. Everybody take a deep breath and let's go and look at some of the specific tools offered by Snyk. Now, firstly, we have Snyk Open Source. Snyk, that is the tool that will scan your open source dependencies and let you know when there are known vulnerabilities. And also, not just let you know that there are vulnerabilities, but give you remediation advice. And oftentimes, one of the greatest problems to have is you get a vulnerability report back from Snyk, but it says all you have to do is bump this patch version from this to that, and the vulnerability goes away. Well, through the magic of semantic versioning, if it is a patch version that you have to bump, you'll have a high degree of confidence that it won't be a breaking change. And that's often the case when you find vulnerabilities. With active, well-maintained libraries, when a vulnerability is discovered, it's usually fixed very quickly. And so if Snyk catches it, you can bump the version, and this vulnerability never sees the light of day. It never gets the vulnerable library version never gets committed into your SEM like GitHub. And so that's one of the reasons that shifting left is so valuable, because you catch these vulnerabilities at a time when it's a lot easier and cheaper, both from the perspective of time and money to fix. All right, so then we have Sneak Code. That's where we look at your custom code, that 10 to 20% of your application that is custom, and we report and give you remediation advice on vulnerabilities that are found. And we even now have this deep code AI fix capability, which I'm going to demonstrate in a little while, where not only do we give you remediation advice, but we can even oftentimes auto fix the problem that we found. We'll see that in just a little bit. Sneak Container scans your container definitions, like your Docker files. It scans your images and reports back on vulnerabilities and gives you remediation advice as well. And oftentimes, switching from one version to another of an image, or a different producer of the same image will fix all the vulnerabilities. And in the world of Java and others, it's very useful, because if I need a Java runtime, my application doesn't care what runtime that is. So if I can use, if Tomcat 8 has a raft of vulnerabilities and I can use Tomcat 9, great. All the vulnerabilities go away just by changing that version. Finally, we have Sneak IAC, and this is going to inspect your Terraform, your Kubernetes, and others configuration files, and it's going to let you know things like everything from bad password policies to open S3 buckets, and everything in between. Now, those are the Sneak suite of tools. We also have a few services at Sneak, and one of them is Sneak Advisor. And with Sneak Advisor, you get a package health score in a number of different ecosystems. Today, we support NPM, PyPy, Go, and Docker. So if you're working in those ecosystems, you can do a search on a library that you're considering using, and we give it a package health score. And of course, security is the number one most important thing, no known security vulnerabilities. But we also look at things like community and maintenance, and that's very useful, because if there is a new vulnerability discovered, you want to have a high degree of confidence that the community that maintains that library is going to fix it very quickly. So if there are no known security vulnerabilities, but the maintenance is low, that's what lowers the overall package health score, because when a new vulnerability is discovered, the update of that library may not happen as quickly as we would like. Finally, we have our open source vulnerability database that all of our tools are built on. And we're both producers and consumers of this database. We have a research team at Sneak that's discovering new vulnerabilities and new issues and updating our database. And all of our tools use the database to report back on the vulnerabilities and the remediation advice that we offer. Finally, Sneak meets you where you are. So you can run Sneak on the command line. We have Sneak extensions for all the popular IDEs. We have a Sneak web interface for you or your administrators. And wherever you most like to work, Sneak will meet you there. And for me, as an active developer and practitioner, I kind of use Sneak in all of these contexts. I use it on the command line. I use it in my IDE, probably most frequently in my IDE, and I use the web interface. The web interface is very useful because that's where you can set up some of the automation rules. And we'll look at that in just a little bit. But among other things, you can tell Sneak to automatically create fix PRs for you when it finds new vulnerabilities, and you can have it scan your project every day to look for new vulnerabilities. Okay, so let's go and hack a web app together. And what I'm going to do here is to share my screen. So bear with me just a second. I'm going to share my entire screen. Okay, do not attempt to adjust your screens. This is my actual background. Again, that chaotic neutral mindset. Whenever I share my screen at work, people sometimes think there's something wrong because they see this dithered background. That's the way it's supposed to be. But here's what I really want to share, and that is the this web interface, and we'll drop the link in there. If you want to join me here, you're welcome to. This is a publicly accessible website, and what we're looking at is a chat app. Now, the interface, I will tell you, is terrible. I am not a good front end developer. Please don't ever hire me for front end work. But this does represent a modern web app. The front end that we're looking at here, this is JavaScript using the Vue.js framework. The back end is Java using the Spring Boot framework, and it's using WebSockets to communicate to give us near real-time chat. So by kind of every definition, this is a modern web app. Now, here you can create rooms, kind of like you can create channels in Slack. If you are going to jump in here, join me over in the main room. So click main room and then click start chatting. So far, I'm the only one, but that's okay. This is chat in all its glory. So I've just said hello. We also get kind of telemetry information, like when people join and when they leave, we can see that. And, it's kind of very utilitarian. It's functional. It works. We can chat. All right. Now, if you've been invited to hack on this app, as I've invited you, well, the very first thing I'm going to try to do is some low-hanging fruit here. So I'm just going to try and drop in a script tag. Anytime I see a web interface that gives me input, I can't help but wondering if maybe they don't have good sanitization or maybe any sanitization. And so I'm going to try this. Looks like Kazi joined. Excellent. Welcome, Kazi. So what we can see here is that there's some level of sanitization because it didn't give me an alert pop-up. It took what I typed and it just converted it to plain text and sent it through as chat. So that's good. That's good from a security perspective. There's some level of sanitization. Now, I'm inviting you to hack on this app. I do have some ground rules, though. The only ground rule is no denial of service attacks. This is a very lean instance. It happens to be running on Heroku. It's a hosting provider. I could probably knock it over with my phone if I tried. So no denial of service attacks. But anything else you want to try, please, I love it when people are able to break this application. If you want to craft some clever JavaScript or interact with the backend, use your developer tools, I am inviting you personally to beat up this app. All right. Well, we can chat. We see when people join and leave, but that's a little boring. Imagine this scenario, and that is I decided, well, I have the bones of my chat app here, but I want to make it a little more interesting. I want to add support for Markdown. And as I said earlier, Markdown is a terse markup language, and you can produce things like a header simply by putting in this little hash mark and a space and then typing a header. So that starts to make things more interesting. Now I can yell at you because I support Markdown. And among the things you can do with Markdown that are very useful are you can drop in links. This is very useful for chatting. It makes the chat a lot more interesting and useful. So here's the anatomy of a markdown link. It's a set of square brackets with a label followed by a set of parens with a URL. Pretty straightforward, right? Now this is a lot more safe and it's a lot nicer than forcing users to have to put in like HTML or something. So Markdown is very useful for chat, and it's one of the reasons that Slack supports it. So when I send that through, you can see, well, this is just a vanilla link. And if I right click it and choose open link in new tab, this is kind of the nothing up my sleeves part of the presentation. You can see that we've navigated over to sneak.io. Now, Markdown does not have support for formatting a link in such a way that when you click on it, it opens in a new window or a new tab. That's why I had a right click. It's a little bit of a shortcoming of Markdown. If you do click away, you can just come back to the front door and rejoin. Okay, this is great. So now I've made my my chat here a lot more interesting, a lot more interactive. But as a putting back on my hacker hat, maybe there's a new vector of attack here. Maybe there's a new vector of attack because I know that what's inside the parens, what a markdown parser does is it just puts that into the href attribute of an anchor tag when it renders it. So maybe I can sneak this past the parser, the sanitizer, because this is like Markdown is offering me a new vector of attack. Well, if I look down here, and Chris, if you want to make a header, all you have to do is put a space between the pound and the H1. The space is important. Now, this time, what's interesting here is that all I got in the output was a closed paren. So this kind of makes me think, as a chaotic neutral, this makes me think, well, it didn't work. I didn't produce a link that when clicked on will make a pop-up, but maybe I'm making progress. Something broke here along the way. It didn't just spit out exactly what I typed, like I saw before when I typed a tag, right? It didn't just spit that back. I got a closed paren. So let me try something a little more sneaky. All right, I guess I hand typed that. So this time I'll remember to, let's see if I can do this without the demo monster getting me. I'll explain what I'm doing here in just a moment. I can't type well and talk at the same time. Okay, let's look at what I'm doing here. Now, you may or may not recognize this. This is called an HTML entity. It's a type of encoding. It's part of the HTML spec. And this is the HTML entity for the colon character. Here's what I'm hoping. I'm hoping that the sanitizer is naive. Maybe it's looking for an explicit string called JavaScript colon. And so if this sneaks past the sanitizer, then the browser will happily convert that to a colon, and then maybe I'll engage the JavaScript engine this way. Ampersand pound 41, that is the HTML entity for a closed paren. And the reason why I'm putting that there is because I know that some sanitizers use paren matching as a way to detect somebody trying to inject JavaScript code into a chat, or to try to get it to render on the page or something. So this is kind of a little bit of insurance. In case the sanitizer is smart enough to match parens, this is the HTML entity for a closed paren, but just parsing through this, it won't match the parens. Okay, this time I'm going to remember to copy it, and I'm going to send it through. And now if we look, well, we got nothing. We got no output at all. Now, other people may be inclined to give up at this point, but I'm like a dog with a bone. I can't let this go. I think I'm making progress, and so I'm going to try one more thing, and I'll give you a spoiler here. And the spoiler is that this is going to work. And this is going to work because of a combination of the browser being too permissive and because of a vulnerability in my Markdown library. All right. Well, what I did here was I inserted the keyword this, but let's take a look at what we have together. And what I meant by the browser being too permissive is that this is no longer a valid HTML entity because it's missing the semicolon. The anatomy of an HTML entity is an ampersand pound followed by an ASCII code followed by a semicolon. So this is no longer a valid HTML entity, but the browser is going to do its best to render it. Browsers are kind of the opposite of security professionals. Browsers are always trying to help. They're always trying to render what we intended to render. So if we leave off a closing uh, tag, if we leave off a closing tag, the browser will still try to render it. If you work in a language like C# or Java, you know that you can't just go leaving semicolons off because then you get a compile time error. Now, let's kind of parse this together. We have the JavaScript keyword followed by a colon, followed by this. Well, this is a keyword in JavaScript. It's often misunderstood, but all this is like a no-op. It doesn't do anything. It's just the handle to the this, but syntactically, it's fine. It's perfectly fine. So then continuing, we have a semicolon. That's the statement separator in JavaScript. Then we have alert one, and I still have this insurance of the closed paren. All right, let's put this through. Interesting. Now I have a rendered link, and when I click on that link, I get this pop-up. Okay, great. Now you might be inclined to say, well, that's such a chaotic neutral thing to do. It's like really annoying, but it doesn't actually hurt me in any way. And the thing about hackers is their goal is to get a foot in the door. And once you have a foot in the door, you can put in more sophisticated payloads. So for instance, I just dropped in a payload that is using 438 of the available 500 characters. And when I put that through, it gives this innocuous looking, totally safe link. Now, for all the people that are here, Jay-Z and Scott Becker and Kazi, I want to invite you to click on this link. I promise it won't harm your computer or anything like that. I'll click on the link as well. And what we're looking at here, if you notice, each of the responses is slightly different. It says super secret cookie pwned, and then it's got a unique UUID here. Well, what we're looking at is in each of our browsers, we have this super secret cookie, and I have now tricked you into leaking this super secret cookie into the chat. Now, this is very bad. This could be your session ID, which could lead to a session takeover. And if it was something like the session ID, I don't know, for your logged in bank account, well, maybe I could take over your banking session. So this is very bad. Now, as we come up to time here, we're going to spend the next few minutes looking at how we got here and how we can fix this as developers. And the first thing I want to show you, this is the application. What we're looking at is the IntelliJ IDE. And we're looking at the code and where I added Markdown support to my kind of basic chat app. And what I want to show you is that I was trying to be a responsible developer. And so rather than reinventing the wheel, I'm using this marked library. Whoops. What did I do here? Bear with me a sec. I'm using this marked library. So that's line one. I import the marked library. Line two is I set a bunch of options, including enabling the sanitizer. Great. I read the fine manual. This is how I set up the sanitizer. That's line two. And then line three is up here. Let's see if I can find it quickly. Uh, Here we go. Line three is for any message coming in on the WebSocket, I want to pass it through the marked function so that if there is markdown, it gets parsed and rendered. Okay, great. So this is a big win from a developer perspective because with a little bit of research, 3 lines of code, less than a half hour's worth of work, I now added markdown support to my application. But of course, as we now know, it's a big loss from a security perspective because I introduced a vector of attack that wasn't there before and is now exploitable in a pretty bad way. So this is where we're going to enter in with Sneak. This is the Sneak IDE extension that we're looking at, and I'm going to run a scan on this code. And there's a couple of things I want to point out here. One is that this is a multi-module project, and Sneak is perfectly capable of handling it. Not only is it a multi-module project, it's a multi-language project. And if we look over here, we can see that the POM XML, that's the Java side of the house, and Sneak found 55 vulnerabilities in the Java dependencies. This is the package JSON, that's the JavaScript side of the house, and it found 60 vulnerabilities. Now, this library or this application is vulnerable on purpose, but what I want to highlight here is the marked findings. And when I click on one of these, it found 5 issues with the marked library in particular. And when I click on one of those, I get all kinds of useful information. I get links to CVEs, I get information about the vulnerability, and I also have this remediation advice fixed in marked 0.3.6. I'm at marked 0.3.5. This particular issue is fixed in 0.3.6. Now, bear with me a second here because this is not right. I'm on 0.3.5. Okay, great. Now, the more useful thing to look at here is this is one individual vulnerability. The more useful thing to look at, actually, bear with me a second here as I rescan this very quickly. The more useful thing to look at is in the dependency file itself. And we'll wait for this scan to finish, tempting the demo monster. There we go. And if you notice, I have the red squiggly line here. And when I hang my mouse over the red squiggly line, now I get a rolled up version, a rolled up view of this that shows me all 5 of the vulnerabilities. And the final remediation advice is that if I upgrade to marked 4.0.10, then all of these vulnerabilities go away at once. All right, now I want to show you fixing this in a different context, and that is through the web interface, which is over here. Now, previously, what I did was in my Sneak account, I added in this, I imported this project, and it did a scan, and we can see all these vulnerabilities for the individual subprojects. So this is the Java side of the house, the JavaScript side of the house. There's a Docker file. There's vulnerabilities in everything. But on my package JSON, I can see that I have 5 high vulnerabilities and 7 medium vulnerabilities. And what I'm going to show you here is how Sneak can come in and create a fix PR for you. And we come right up to the edge of fixing the vulnerability for you, but we want that last mile of human interactions. Now, this is something that you can automate. You can have it regularly scan your project and create a fix PR. I'm going to do it manually here, and I'm going to tell Sneak to fix these vulnerabilities. And it's going to open a fix PR in my GitHub account. Again, tempting the demo monster. Come on, Sneak, you can do it. So it's going to create a fix PR that's going to address all of the vulnerabilities in that one subproject that I highlighted in the package JSON. And it gives us all of this really super useful information. This is a very detailed PR. I don't know about you. I've never created a PR that's this detailed. But at the end of the day, if we look at what's actually changed, the only thing that's actually changed is we're bumping this version from 0.3.5 to 4.0.10, exactly what we saw in the IDE. I'm going to merge that pull request. And what we showed before was, if you remember, we had 5 high and 7 medium vulnerabilities. As soon as we merge, it triggers a rescan of the project in Sneak, and you can see that we've now gotten rid of all the high and most of the medium vulnerabilities here. So it automatically, you can see that a new scan was run just a few seconds ago. By merging that PR, it automatically did that scan. Okay, back to the slides as we hurtle toward the end here. Bear with me a second because I want to provide you with some nice resources. Okay, and I know we're coming up against time. I apologize for that. I can stick around longer at the top of the hour if there are questions, but I want to give you a couple of useful resources really quick here. One is we have these great cheat sheets at Sneak. If you go to sneak.io, you can find them. We produce them along the different dimensions of languages, frameworks, things like Kubernetes or the OWASP top 10, OWASP top 10 for LLMs. Super useful. We also have these learning paths at learn.sneak.io, and it's really nice because it's completely contained within your browser. So you may do a Sneak scanner, you may execute a command line command like the Sneak CLI or a curl command, but it's all within your browser. So you don't have to install any new software, and you can really get some experience and some learning through there. We also have a YouTube channel that's produced by our very own Brian Clark. He's extraordinary, and he has lots of really good interviews and lots of really good advice on how developers can improve on their security practice. We also have Try Hack Me rooms. If you're not familiar with Try Hack Me, usually it's a for pay site where you can go through these different learnings. Sneak has produced free rooms that you can go to and learn more about the tools. Today I demonstrated Sneak open source, but you can learn about Sneak code, Sneak container, Sneak IAC there as well. So finally, we have sneak.io/community. That's where you can join our DevSecOps Discord, and we have a lot of activity, and we're very responsive there as well. So we're right at the top of the hour. I'll pause here and see if there are any questions that I can answer. Thank you so much for attending today and for your time and attention, and happy to answer any questions you may have. Hit
Yeah,
me.
that was fun. It's not every presentation I get to click on a totally safe link and have my my cookie details exposed. We do have some interesting questions here. One from Rakesh, who's wondering. Rakesh has two questions. And the first one is there a way to skip previously discovered vulnerabilities and break only on new things that are discovered in a scan?
Yes and no. Maybe not exactly the way you're describing, but you can go into the Sneak web interface in the admin console and you can say, this low priority vulnerability that keeps popping up, we don't care about it, or it's unreachable, or we're going to deal with it some other time. And you can tell Sneak to skip that in future scans. And then whether you're in the IDE or you're in the browser, that those low vulnerabilities will no longer show up. So you can kind of, tweak the noise to signal ratio that you get by ignoring vulnerabilities that either you don't care about, they're unreachable, you're going to get rid of for whatever reason. So I think that mostly addresses the question, but not exactly as you posed it.
Okay. And the other part of Rakesh's question is, are there limits in the types of files that Snyk will scan in a repository?
Well, there's a limitation from the perspective of supported languages and then files that go along with those languages. So we support most languages. Just as an example, I don't believe we support Haskell. So if you have a Haskell project, the Sneak Scan probably is going to ignore most of those files. But if you have any of the supported languages and frameworks, if you, like I showed, a very complex, multi-language, multi-module project that in addition to language files for JavaScript and Java also had a Docker file in it. So Sneak will scan all of those files and we'll provide you that feedback.
Okay. All right. We probably got time for one more here. Ned is wondering, how does Sneak's security and vulnerability data compare to other vulnerability databases?
Well, Sneak is the best, obviously. Uh, well, yeah, I don't know a precise answer to that question. I do know that through our open source vulnerability database, we're one of the few companies that is both a producer and a consumer. So we're not just using another database. We're providing our database for others to use, but our research team regularly contributes to that database. So it's ever expanding.
Okay. Excellent. Well, Mike, I think we're going to have to leave it there, but thanks so much for really interesting and fun demos and presentations. Really appreciate your time today.
All right, you bet. Thank you, and thanks to everybody that joined.
All right. And before we wrap up, we do have one more piece of business, and that is the Amazon gift card prize drawing. And the winner of the $250 Amazon gift card today is Carrie Preisel from Connecticut. So congratulations to Carrie. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Sneak again for making this event possible. And thanks as always for attending and for your great questions. We will pass along all the questions that we didn't have time to get to here along to the Sneak team for follow-up. But that's going to conclude today's event. Have a fantastic rest of your day.